In this video, we'll demonstrate the relationship between exponents and logarithms. First, let's take a look at an exponential function. This is the graph of 10 to the x power. You'll notice that it's an increasing exponential function. This is the graph of e to the x power. Now e is Euler's number, 2.7. So this is the graph of 2.7, or e to the x power. Just like pi is 3.14, e is equivalent to 2.7. You'll notice that e to the x has a slower exponential growth than 10 to the x. So as your base increases from 1 to infinity, the function will increase faster. Now let's take a look at the logarithmic function. Going back to just the function 10 to the x power, we're going to reflect it about the line y equals x. We've now reflected 10 to the x across the line y equals x, and the red line is the graph log base 10 of x, or the inverse function of 10 to the x power. The green line is the exponential function, the red line is the inverse or logarithmic function. Now we'll do the same comparison with the exponential e to the x and its inverse function, the natural log of x. You'll notice in the green exponential graph that a larger base grows faster than a smaller base. However, in the red graph, you'll notice smaller bases grow faster than larger bases. In summary, exponentials with larger bases grow faster, but with the logarithmic function, smaller bases grow faster. Next, we want to consider what happens when you take the opposite of a logarithmic graph. This is a graph of log base 10 of x. And if we take the opposite of this graph, all of the negative values become positive, and all the positive values become negative. This is the resulting graph of taking the opposite of the log of x. You'll notice that it's reflected about the x-axis. We can do the same thing with log base e of x. Here is the graph of log base e of x. And now we'll take the opposite of log base e of x. So the opposite of log base e of x is just a reflection of the graph about the x-axis. The final concept we'll look at is taking logs of base less than 1. This is the graph of log base 10 of x. This is the graph of log base 5 of x. This is the graph of log base 2 of x. As the base of the log gets smaller, the graph grows faster. Now let's look at the graph of log base 1/2, log base 1/5, log base 1/10. You'll notice as the log base decreases from 1 towards 0, the graph exhibits logarithmic decay, with bases closer to 1 exhibiting faster decay than bases closer to 0.